Okay, so previously we did the tangent ratio. Today we'll be doing, both the sine and cosine ratios. I'm telling you, some people and their yard art. I think you gotta be pretty crazy if you are gonna go Flintstones for your yard art. Sine and cosine ratios. Again, we're going to be looking at a right triangle. Again, we have to focus on one of the acute angles. If I want to know the sine of an angle, I need to use the opposite side divided by the hypotenuse. If I want the cosine of an angle, I'll need the adjacent side compared to the hypotenuse. Okay, so we're going to find not one, not two, not even three, but four things here. I want the sine of angle S, the sine of angle R, the cosine of angle S, and the cosine of angle R. We'll do each one as an exact fraction, and then we'll also do each one as a decimal rounded to 4 places. So, sine of S, opposite over hypotenuse, that'll be 63 over 65. So there's an exact answer as a fraction. If I grab a calculator and divide, about 0.9692. Sine of angle R. Now the opposite is 16, hypotenuse is 65. That fraction will not reduce, but I can grab a calculator, get a decimal approximation, 0.2462. Cosine of angle S. Now I need adjacent over hypotenuse. In this case, 16 over 65. That's an exact answer. I can do a decimal approximation. Cosine of angle R. Now I'll need adjacent over hypotenuse. Adjacent to R is the 63. Hypotenuse is still 65. And again, I can do a decimal approximation. Now, if you're really sharp, you might notice something. You might notice that the sine of S has the same answer as the cosine of R. You might notice the cosine of S has the same answer as the sine of R. Right? There's a reason why sine and cosine are getting introduced at the same time. And if you want to know why this is true, come back next lesson. Okay, so let's find values of x and y using sine and cosine. Round answers to the nearest tenth. Okay, so since 26 degrees is the marked angle, I know sine is opposite over hypotenuse, so I can use the sine of 26 degrees to help find x because that's opposite. I can use the cosine of 26 degrees to help find y because that's adjacent. Okay, so we use sine because sine is opposite over hypotenuse. So the sine of 26 degrees will be x over 14. Let's multiply each side by 14. That gets x isolated. Grab a calculator. Come up with about 6.1. Right, with a calculator, I did 14 times the sine of 26, making sure I set for degrees. rounded to the nearest tenth, 6.1. Okay, that's x. Let's get some room and do y. Again, I'll use cosine because y is the adjacent leg to 26 degrees. And of course, the hypotenuse is still 14. That's not going to change. Multiply both sides by 14. Grab a calculator. Right, I did 14 times the cosine of 26. Again, making sure I'm set for degrees. So about 12.6. How am I going to do this? Well, again, if I don't have a picture, I better come up with a picture somehow. Right, so Bob Ross will come back and he'll paint, no. Let's get a triangle instead here. And I need a right triangle with a 45-degree angle. Of course, if one of the acute angles is 45 degrees, to make it add up to 180, I guess the other angle has to be 45 degrees. Hey, it's our friend. It's the 45, 45, 90 right triangle. I know what numbers to use. Right? We're going to use 1, 1, and square root of 2. That's one of those special triangles. Okay, 45-degree angle, choose one of them. So sine of 45 degrees, opposite is 1. Hypotenuse is square root of 2. So we've got an answer of, oh man, I can't be an answer. Can't have a square root in the bottom of the fraction. Let's multiply by the number 1. But we disguise the number 1 as square root of 2 over square root of 2. In the denominator, root 2 times root 2 is root 4. Square root of 4 is plain old 2. Ah, much better. Sine of 45 degrees is root 2 over 2. Now, for the cosine of 45 degrees, instead of opposite over adjacent, instead of opposite over hypotenuse, I need adjacent over hypotenuse. Of course, the adjacent leg is 1, the hypotenuse is root 2. Same situation, I do not want a radical denominator, so I can rewrite that as root 2 over 2. Okay, and SOHCAHTOA is what helps my memory out here. That reminds me that sine is opposite over hypotenuse. It reminds me that cosine is adjacent over hypotenuse. It reminds me that tangent is opposite over adjacent. SOHCAHTOA. That's a memory device. Bob Ross, what did you do to us here? Let's get that out of the way. Instead, it looks like, a double header. It looks like we're going to have a worksheet. And it also looks like there's an IXL with the trig ratios for sine, cosine, and tangent. And again, what some people's yards do with their yard art is beyond me.